Good morning and welcome to today's lecture on sections 11.1 through 11.3 on cost estimating. Again, as I always start off, referring you to the Start Here page on Blackboard where you should review the schedule of assignments. The pages you should read for today's lecture is 327 through 338, and you should be responsible for the lecture notes that I will upload as well as the video. And if you want to make a good grade in the course, you should work as many problems as you can at the end of each of the chapters. So we'll start with section 11.1, which has how to make cost estimates, and the author talks about the importance of getting your cost estimates correct or as close to as accurate as can be, because they affect pricing decisions, and we know that if we price a product or a service too high, we'll make quite a bit of profit, but we may not make very many sales because our competitors will beat us on price, and so we'll miss out on sales. If we price a product too low because our cost estimate was error on the low side, we will be very competitive on price, but we won't make any profit. Neither of these two scenarios is very healthy for a company that is trying to sell a product or a service. So you want to price the product correctly. In order to do that, you have to have good cost estimates. So that's the justification for spending time and effort doing cost estimates. The costs are broken down into two categories generally: direct cost and indirect cost. Direct cost are cost elements that go directly into producing the product or service. So things like that fall into direct cost would be materials. Certainly, if you're making a product, the materials cost, the labor cost, production equipment and facilities. Those things are part of the direct cost of manufacturing. Maintenance and operating costs that we usually estimate, and direct supervision. First line supervision can be part of direct or indirect. Really, it's kind of on the balance there, or in between. Most people would say if a first line supervisor is part of direct cost, whereas higher level supervision would be, or plant management would be, indirect. So under indirect cost categories, we have things like utilities, the electric bill, the gas bill, and so on. The management staff and headquarters, the headquarters building. If it's not a manufacturing plant, then that building would be part of marketing cost. Indirect cost, information technology services, accounting, purchasing, security, quality control, warranties and guarantees, and legal. All of those would fall under indirect cost. Very easily. The things that I'm thinking about right now: quality control. If it's manufacturing quality control, it could come under direct cost. But these others, Purchasing, accounting, warranties, guarantees, legal, marketing, all of those are indirect costs, easily categorized. So we want to estimate direct costs first, and we're going to have what are the components. So we have to answer 4 questions. First of all, what are the cost components? Materials, labor, as I've listed up there. That must be estimated. What is the estimation approach for this particular thing? A top-down approach basically starts with a price and says, okay, if this product is selling on the market, and you're going to compete with that, what are they selling it for? So you start with a price, then you put in your profit margin and subtract from the price your profit margin, and that gives you your total cost, and then you would break that down further. So that's a top-down approach where you start with what is your total cost got to be, and then break it down from there. That's called design to cost. In the aircraft industry, we used to do this all the time, because sometimes the management of the company would be told by someone in Congress or some customer that this is the maximum we can pay for this product, say this new aircraft, and you have to design and build it for that price or produce it for that price. So that was part of what we call design to cost. So you would then come up with design parameters that the product could meet those required costs. That would be a top-down approach. A bottom-up approach is where you start with direct materials, direct labor, and you start building those up and adding them up until you get to the total cost. So those are the 2 approaches. In one case, you start with the total cost and then go down the line, so to speak. And then another one is you start with the components and you build them up to get a final price. And so that's the second question, so to speak. What approach are we going to use to estimate the cost? What is the level of estimation correctness? And that is kind of put into this figure. This figure down here is figure 3 in your textbook, and it basically says the more time and effort you put into making the cost, the less uncertainty. This vertical axis is the degree of error that might occur. And certainly if you use a very simple cost estimating, you may have more error. If you get very sophisticated, spend a lot of time and effort, you may get more accurate. Okay, the level of accuracy is increasing as the level, this is the error level here on the vertical axis. So this is the level of error decreases as the time and effort increases. So that's just kind of logical. And the author talks about order of magnitude estimates. That'd be 20 to 50% error, possibly. And then detailed design cost estimates, plus or minus 5% range. So, of course, that's relative to what you're estimating. If you're estimating a consumer product, you really need to be definitely within that range because of the high level of competition and the fact that this thing has already been in production and so on. If you're talking about a brand new aircraft, then you probably are closer up into this range because it may not be fully designed yet, and the technology to create this aircraft may not even be developed yet. So in that case, you're probably talking, in the early phases, you're talking about order of magnitude estimating. The final thing is, what is the technique are you going to use? And the author presents in this chapter lots of techniques. Tables, you can go to tables, you can use software, you can use what's called the unit method, you can use cost indexes, factors, all of these things, cost estimating relationships. We use these. These were statistical relationships that related the cost of an aircraft to, for example, things like the engine thrust, how many, and the weight of the aircraft, and what kind of speed it had to achieve, the maneuverability of the aircraft. All of these things were part of our statistical cost estimating relationships with creating basically military aircraft. Learning curves, that is, that as you produce more and more of a product, you get better and better, you get more efficient. And so learning curve method is a method of estimating cost. Expert opinion, and then comparison. For example, if you went to a realtor and you wanted to get an estimate of how much your cost is worth, your house is worth, a real estate agent would do comparisons. They'd say, well, this house is a little bit bigger than yours and it's in the same neighborhood and it's sold for so much. Since yours is a little bit smaller, yours would probably sell for this much, which is a little bit less than what that one sold for. That would be a comparison method, and that's used in real estate a lot, for example. Now, the estimating error is the estimated cost divided by the actual cost minus 1 times 100%. And if you underestimate the cost, then this is going to be, this number here, this ratio is going to be less than 1, and so you're going to have a negative, when you subtract 1, you're going to have a negative estimating error. If you overestimate it, this ratio here will be greater than 1. You subtract 1, it'll still be greater than 1, so you'll have a positive estimating error. So this is the way the author defines estimating error, and that's the vertical axis on this figure 11.3. So the next thing we're going to talk about then is some of the specific methods. Remember, that was one of the question is what method are you going to use, or what technique are you going to use to get the cost estimate? So the first one and the most simple of all methods is called the unit method. Okay, in the unit method, that's equation 11.1, you simply say the total cost is equal to the cost per unit times the number of units. Okay, it sort of makes sense. For example, if new home construction costs in Beaumont, Texas have been running $100 per square foot of living space, and a new home design has 2,000 square feet of living space, then the estimated construction cost is you take the unit cost, $100 per square foot, multiply that times 2,000 square feet in this particular design, you get $200,000 as the estimated cost to build that house, to construct that house. That's a very simple method, okay? The author gives another example of the unit method, and in this one, for example, materials are estimated to be the number of materials you're going to need is 3,000 tons, and the cost is $45.90 per ton. Then the total estimated cost for materials is $137,700. And then the author in this particular case gives machinery, tooling, 1,500 hours are required for this product or service or whatever it is, and the cost is $1.20 an hour. I'm sorry, $120 an hour, and so you multiply that times the 1,500 hours, you get $180,000, and so on. I'll let you read the example in the notes or in the book, either one. So the next method is called the cost indexes. Using cost indexes, and this is where you may want to translate from one point in time to another. We already talked earlier in the semester about the Consumer Price Index, and that's an index that the U.S. government keeps, and it keeps it over time, and it represents the weighted average cost of goods and services that the American family might purchase. And I, for example, have looked up the Consumer Price Index over, and you probably can't see this because it's maybe too small of type, but what I have is the year starting in 1913 all the way to 2020, and I have the January Consumer Price Index, the December Consumer Price Index, and then I take from one December to the next and get the inflation rate for that previous year, or for that year, I'm sorry, for that particular year. And so we have, for example, if you look at the recent 10 years, the inflation rate or the Consumer Price Index has been increasing at, generally speaking, about 2%. Some years are less. There's a year, 2010, when it was 1.5%. In 2011, it was 3%. 2012, 1.7, 1.5, and so on and so forth. I'll post this with the lecture notes on Blackboard. But you can see, let me put it back up here, that recent years, the inflation rate's been very low, like around 2%, as I said. But if you go back to 1979, the inflation rate was 13.3%. 1980, it was 12.5. Those are huge. Back to the end of World War II, 1946, it was 18.1%. Those numbers are not very tame. So inflation does fluctuate a lot over longer periods of time. We're going to use cost indexes, though, to estimate costs of a product or service when we know what the cost was maybe at an earlier time. And so the author presents in this table here that's in the book the different kinds of indexes. For example, this particular column from 2010 to 2018, he has the CEPCI, which is the Chemical Equipment Plant Cost Index. And the numbers range from, 55.8 down to 550.8 down to 607.0 for that particular index over that particular number of years. The author also has the Consumer Price Index, CPI, the other indexes here. He calls this column the FRED Index, which is Federal Reserve Economic Data Index, and so on. So the author recommends a couple of websites in the book. One of the websites is not active anymore, but the other one is listed here in case you want to look it over for cost indexes. It's certainly not part of this course, but the main equation of translating cost or estimating cost, total cost, from one period to another is you take the cost that's known for an earlier time period and you multiply it by the ratio of the two indices. So if I wanted to know what the cost, say, of chemical plant equipment would be in 2018, I would take this 607. If I knew what the cost was in 2010, which is 550.8, and I take that ratio of the cost indexes multiplied by the known cost back in 2010, and that would give me the cost in 2018. And the author then gives you an example in this particular case. He says construction project cost $1.44 million 5 years ago. The skilled labor component of that was 25% or $360,000. So we spent $360,000 on labor 5 years ago when he said the index was 4,038. But now the labor cost index is 4,681. So how much would the labor cost be now? And you just apply equation 11.2 to this data, and you get $360,000. That was the 5 year ago cost times the ratio of the two indices, the 4,681 divided by the 4,038, and you get 417,326. And then he carries this example one step further. He says, suppose that the actual labor cost this year ended up not being this estimated number, but rather it was $500,000. Okay, 500,000 there. And he says, well, what was the actual index then this year? And you multiply equation 11.2 through and solve it for I sub t. And then you get I sub t equals I sub 0 times the ratio of the two cost numbers. These are now both actual costs. And this would be the old index, 4,038, times the ratio of the cost, which is 500,000 over 360,000. It says the index should have been 5,608 instead of what we estimated or what it actually was, 4,660. That's kind of a hypothetical. The second part is hypothetical because the fact of the matter is the index is what it is, but maybe you did not achieve that low a cost as what was estimated. So that finishes off sections 1 through 3. So I've worked a number of problems for you. These are problems that were taken out of the prior edition of the book. So problem 1, example problem 1 is, for cost estimating purposes, there are several examples of first cost components, P. List 3 of them. And I said, well, equipment cost, that's always an upfront cost. Delivery charges and installation costs. By the way, these 3 types of costs are all, when we get to a future chapter where we talk about depreciation, these are depreciable costs, all 3 of those. They go into the actual first cost of a piece of equipment, because certainly you can't use it in your production process if it's not delivered and it's not installed. And so all of those are part of the original cost of the item. Okay. There's also insurance coverage and initial training and of personnel, especially in the aircraft industry where I have some experience. Training people to fix the airplanes, a newly designed airplane, was a big thing. So that was all part of the delivery charge of the airplane. Example 2. When the competition is the dominant factor in pricing a product or service, what is the best cost estimating approach? Remember I said, if you know what you have to be able to sell it for, you use the top-down approach, okay? Example problem 3. The unit area and unit volume total project cost for a library are $114 per square foot. So that's the unit area cost factor, so to speak. And the unit volume is $7.55 per cubic foot. So this is a volume factor. This is an area factor. On the basis of these numbers, what is the average height of the library room? So he goes in and says, well, to get height, you need feet. And to get feet out of these two things, you divide the cubic feet by the square feet. And, you divide cubic dollars per square foot by dollars, divide dollars per square foot by dollars per cubic foot will give you feet. So you divide this by this. Here we're just kind of keeping track of units like we did in our physics class. And so we have the answers, the unit of measurement that you need is feet. And if you divide dollars per square foot by dollars per cubic foot, you get feet. Okay, so the average height is $114 per square foot divided by $7.55 per cubic foot equals 15.1 feet. And so that's the average height that you get out of that. That's a kind of a different kind of a problem, I would say. Example 4, it doesn't use one of the formulas we talked about in chapter, the first part of chapter 11. This next problem does. It says, example, equipment necessary to manufacture adjustable ball lock pins for pulling components together had a cost of $185,000 when the equipment cost index was 1,375.4. What is the cost estimate for a similar system when the cost index is 1,634.9? So you're going to multiply the ratio of these indices times that prior known cost to get the cost estimate. So C sub t is C sub 0 times I sub t over I sub 0. And that will be 185,000 times 1634.9 divided by 1375.4, and that gives you 219,900. And then example problem 5 is very similar. It's using that same equation, 11.2. And in this case, it's dealing with lumber and the cost per board foot. And the cost of lumber per million board feet, MBF, million board feet, was $364.49 when the cost index was 2,583.52. This would be the cost index for lumber. If the cost was the value, this shouldn't be what, was the value of the index when the lumber was $400. So the lumber costs $400 per MTBF. So we must use this equation, C sub t, that's equation 2, 11.2, and then solve it for the index. If the cost was the value of the was 400,000, when the value, what was the value of the index? Okay, so we're solving for the value of the index when the cost was $400 a million board feet, and so we So we first go through this. We take this equation, and we're looking for I sub 0, okay? And so we multiply both sides through by I sub 0, and we get I sub 0 times C sub t equals C sub 0 times I sub t. And then we divide through by C sub t to get I sub 0 isolated, and that's what we're doing here. And then you end up with the index must have been 2,224.82. So I'll let you read through these example problems, and then the last thing I have that I'll post is that consumer price index. It's not something you need, but since I talked about it in the class, I'll post it with the lecture notes, and you can print it if you desire to see those numbers. And that'll conclude today's lecture.